So in section 3.1, moving from qualitative to quantitative description, this is our context. So we're going to have a sample data distribution. Right? So to refresh your memory, we have sample data with, a sample size n. And we might be talking about, discrete data, continuous data, or categorical data, right? And depending on what type of data we have different ways of thinking about the characteristics of the data distribution. So this is a picture of a histogram, right? The same one that we had in the previous video, but the distribution itself, right, is the sum of all these different notions about how the data are arranged and how they are basically relative to a center or relative to each other, what the data look like when you put them on a histogram. So again, Boston Marathon data, right? We have several thousand individuals who run the Boston Marathon. So our sample size is very, very large here, right? So we get a very detailed histogram, and you'll notice that we're working in this particular case, right, with continuous quantitative data. Quantitative, I think I spelled that wrong. But we'll see examples with other kinds of data. This is the most finely precise data that we can get, so histograms are a really good tool to use here. And so we're going to talk about two different kinds of characteristics that we can actually kind of tell just from the histogram itself. So the first is modality. And so we have two different kinds. So modality. And if you pay attention in a later video, to this part, mode, it is referencing a statistic that we call the mode that we'll cover in a later section. So we have two different kinds of modality. So we have unimodal data or multimodal data. So before I get into the definition, some important things to note here: uni and multi, right? These two prefixes. Uni means one, multi means many. And so with unimodal data, there is one clear peak, right? One kind of data value. So one data value that occurs most often. One data val occurring most often. And you can see here from the histogram, there's kind of this clear peak at around the 4-hour mark. Okay, so this is the most frequent kind of, or this category, this class is the most frequent in the entire data set. So we would say that this distribution appears to be unimodal. So unimodal. If we had two modes, right, if we had another peak somewhere else, like maybe if this bar was taller, then we would call it bimodal. Or if it was 3, trimodal. But usually we just refer to unimodal or multimodal, okay? So specifically, if there is one largest frequency, so if there is one largest frequency in the frequency distribution, then we say the distribution is unimodal. And if not, then it would be multimodal. Or, in some cases, if it all is about even, which we'll see an example of, then this doesn't really apply. Okay? So that's modality. And like I said, we're going to make it more precise when we talk about modes. Right? This is from a histogram. Histogram, by definition, comes from a frequency distribution, which is summarized data. Sometimes, so when we get to section 3.2, we will actually talk about what it is like to calculate a mode or to find out if the distribution is unimodal from the raw data itself. Okay, skewness on the other hand, let me pull in that histogram again. Skewness on the other hand, we have basically two and a half kinds, okay? So skew or to skew is a verb or a noun that refers to leaning one way or another, okay? So there are two kinds of leaning, and there's one that's like the absence of leaning. So skewed left is when, if you look at the histogram or the dot plot, then the left tail is longer. And when I say tail, so if you think about this distribution, right, there's fewer, the frequencies on the edges are much lower than in the middle. So these would be the tails. This is like the left tail. And right now we're being very imprecise, right? What exactly constitutes a tail is subject to interpretation. But roughly we're saying, you know, the leftmost and the rightmost classes. And so if you see that the left tail is longer than the right tail, so roughly here's where the right tail starts, roughly there's where the left tail starts, then we would say this is skewed left. On the other hand, we could have skewed right, where the right tail is longer. So in context here, what we're talking about, if this is Boston Marathon sample data, right, a skewed left distribution would mean that there are fewer people in each individual category of finish time, but on the right side, there are way more people concentrated, and it would look roughly more like, so here's what a skewed left distribution would look like, sort of. So the hump or the middle or the center is to the right of, more to the right. On the other hand, this is a skewed right, or you can argue that this is skewed right because the right tail is longer, which means there are much more people who have, you know, these longer finish times, starting around the 5.5 hour mark. And there's just fewer people, but there's more different finish times on the right. So there are more people finishing slower, but the different kinds of slower, right? So 6 hours or 7 hours, there's fewer in between in all of those, right? So this would be a skewed right distribution. And when I said the absence of both, or, you know, sort of not skewed in either direction, we would call that roughly symmetric, okay? So symmetric is when the left tail and the right tail are about the same. Tails are similar. And what that roughly means then is that if you look at it, it would look more like the center is right at the center of all the data. Okay, so the hump is right in the middle, not necessarily to the left or to the right. And what that would indicate is that there are just as much variation among the higher performance runners as the lower performance runners, right? So almost all distributions that are quantitative can be interpreted in terms of skewness. Sometimes it doesn't apply. Skewness typically only applies if we're looking at a unimodal distribution. Okay, so if there's one clear peak or one hump that pops up in the distribution, then it makes sense to talk about being skewed left or skewed right. There is a more precise definition of skewness that we may talk about in the later section, but that's typically reserved more for advanced stats classes. So And then to clarify, modality also applies to categorical data, but instead of looking at histograms or looking at a quantitative frequency distribution, we'd be looking at a bar chart or a categorical frequency distribution.